Most people hear AI agent and picture a chatbot with a better prompt. But a real agent is not just a talking model. It is a small system built to reason, act, check results, and keep going toward a goal. The difference shows up the moment the work becomes multi-step. If the job is to find the latest invoice, summarize it, send it to an accountant, and update the CRM, one answer is not enough. A language model can explain what should happen, but it cannot reliably manage every step on its own. The missing piece is architecture, the parts around the model that turn words into controlled execution. By the end of this video, you should be able to sketch the core parts of an agent architecture and explain why each part exists. That is the difference between repeating buzzwords and actually understanding the system. The first problem is goal understanding. The system has to know what the user really wants, what success looks like, and where the boundaries are before it touches any tool. Next, the agent has to break the request into steps. Search first, then summarize, then send, then record the outcome. Without decomposition, the system becomes vague and error-prone. It also has to observe the results of each step. If the invoice search fails or the email API returns an error, the agent cannot just pretend success. It has to retry, switch approach, or stop safely. Only after the steps complete does the agent return a final answer. That answer should reflect real work completed in the outside world, not a confident guess made inside the model. Start with the LLM. The model is the reasoning engine. It reads the current context, compares options, and proposes the next move. That is why people call it the brain of the agent. But the brain still needs structure. The planner turns a broad goal into a sequence of concrete actions. It is the component that says, do search first, then summarize, then send, then update the record. Planning matters because it reduces drift. Without a plan, the model can jump between ideas or skip important checks. With a plan, the system can compare progress against an expected path. This is the first senior level lesson. The model and the planner are related, but they are not the same thing. One reasons about language. The other organizes work so the rest of the system can execute safely. If the LLM is the brain, tools are the hands. Search, databases, browsers, APIs, email systems, and file access are how the agent touches the outside world. A mature agent does not call tools randomly. It selects the right tool for the current step. If the task needs the latest invoice, search or storage may be right. If it needs delivery, email may be right. Then the executor actually runs the step. This is the part that turns a planned action into a real function call or API request. In production, this is where side effects happen for real. And this is where permissions matter. Reading an invoice may be fine. Sending an external email or updating a CRM record may require stronger controls. Real systems separate what the agent can think about from what it is allowed to do. After a tool runs, the observer reads the result. Did the search return the right invoice? Did the email API accept the message? Did the CRM update succeed? Observation is how the system stays grounded in reality. Memory is what the agent remembers between steps. That can include the current plan, what already happened, user preferences, or prior actions. Without memory, every turn risks becoming a reset. Guardrails are the safety rules around the loop. They can block risky tools, require human approval, limit what data may be exposed, or stop the agent from taking an action outside policy. And finally, logs and tracing tell engineers what happened. Which tool was called? What came back? Why did the planner choose that step? Without logs, an agent that fails in production becomes almost impossible to debug. Beginners usually build a straight line, user prompt, LLM, response. That is fine for a demo or a simple assistant, but it is not a real agent architecture. That design breaks as soon as you need reliability. There is no plan, no state, no tool governance, no retry logic, and no audit trail. It can sound right while still doing the wrong thing. Senior engineers build a loop instead. User goal, planner, tool selection, execution, observation, retry, final response, and logs. The loop is what makes the system governable. They also care about the operating realities: reliability, observability, permissions, cost, latency, testing, security, and human approval. Those concerns are what separate a clever demo from a trusted system. Now let's walk the architecture exactly as a senior engineer would draw it on a whiteboard. Start with the user goal at the top. That goal flows into the planner because the first job is deciding the path, not guessing the answer. From there, the planner hands context to the LLM reasoning engine. The model thinks about the next move, and the tool selector maps that decision to the right capability. Then the tool selector reaches the tools: search, database, email, or API. After the call, observation reads the result, and memory plus logs record what happened, so the next step stays grounded and traceable. Only after that loop is complete should the system produce the final answer. That answer is trustworthy because it is backed by planning, tool use, observation, memory, and logs, not just by fluent language. Here is the senior level takeaway. A beginner builds an agent that works once. A senior builds an agent that can be debugged, monitored, retried, and trusted in production. So when you hear the phrase AI agent, ask better questions. Where is the planner? What tools can it use? What memory does it keep? How does it observe results? What are the guardrails? Where are the logs? That is the pattern to remember. Let the model reason, but let the surrounding system verify. Trust does not come from impressive wording. It comes from governed execution. Next, let's compare AI agents with chatbots and RAG systems, because those three ideas are constantly confused. If you want more practical AI engineering breakdowns from a production mindset, follow the next lesson.